Hey guys, what's up? Welcome back to FTC. So today we're going to be doing a little physics lesson. So today we're going to be showing you guys how to do Physics 3 without all of the calculus and other prerequisites that these scam schools will lead you to believe you need. So we're just going to dive right into it. Alright, so a lot of like one of the first steps in physics you need to know is you need to know how to give the distance of vectors. So they try to tell you that you need calculus to do that, but I'm going to show you how to do it with a little program called, I'll put it in my AutoCAD program in a second. So yeah, you gotta make sure you have AutoCAD ready and installed. It's free for a lot of schools. They just give it to you if you're like at an engineering school or something. So yeah, we got this right here. So we have our vector. So we gotta figure out how long this vector is, right? So I actually invented this method, and they don't want you to know about it. Schools don't want you to know about it. They want you to have to pay for their stupid classes, which is ridiculous in my opinion. So anyway, we got our vector right there. How long is it? That's what we need to know. It's not that complicated of a question. So what we got to do is figure out something that we do know how tall it is. So for example, I am a big Despicable Me fan, so Gru picture Despicable Me. So yeah, so we're gonna go look for a picture of something that we do know. And since I'm a big Despicable Me fan, I really like Gru from Despicable Me. This is a great picture of him. He's standing up nice and straight. I know exactly how tall Gru is from Despicable Me. Just for those of you who don't know, Despicable Me Gru is Gru from Despicable Me height. He is about 15 feet tall. Yes. So cool. So we got Gru right here. So we know one Gru is 15 feet long, right? Easy peasy. So we're just gonna go back to this. We're gonna go back to our program. We have our Gru. So we have our reference measurement, which is the technological term for it. So we're just gonna paste the Gru right in, make him a little smaller. So we got our Gru right here to measure it, and we're gonna see how long this vector is, right? So we're just gonna transparent selection. Let's get this vector. So problem here, it seems we're having some kind of interference. I don't know what's happening.
Cease watching this video now! My name is Todd Howard, President of the U.S. Education System. Everything you are hearing from this man is not true! Going the same information that is free online at Ford Technical College YouTube channel and a public university for thousands of dollars a semester. If you do not, I cannot afford to perpetuate the legislature of legal baby murder so that I can control the population by putting poisonous aborted baby fetuses into the U.S. population via vaccine.
We're gonna do something. It's called time dilation. It's called time dilation, which is a physics term that you don't really need to know what it means. But to measure this in AutoCAD, we're just gonna do this. So it's called rotate. So first we want it to be long. So we're just gonna rotate it like this. So we're gonna do like a BAM, dude. So we lost a little bit of it there, but that's okay. We'll just measure this new part. So we got this vector right here. Got our Gru. Now we need to be even more straight. I'm a physics major, so I like to be precise with the measurements. So we're gonna make sure it's exactly straight. It doesn't matter that it's a little like cut off, but it's fine. It's fine. So anyway, what we're gonna do here, I know how to use this program very well actually. It's called AutoCAD. So we're just gonna rotate it, a custom degree measurement. Yeah, so I'll be right back after I rotate it real quick. Yeah. BAM! Boom! Okay, cool guys. So yeah, so looks like we just I just fixed this. I made it a straight vector. it was just my program was having issues. It's a very simple process, and I know how to do it. But I just had to restart my program, and look, it looks great. I rotated it, and this is exactly the right proportions. So yeah, we have it all good to go. So we got our groove, we got our arrow. So now we're gonna figure out how tall this arrow is. So it's a simple process. We're just gonna start with so we know that it's at least one groove. So let's see how many other grooves can we fit in there. So copy, paste. So we got we need a little more groove there. So let's go to about here. Copy, paste. So we do a little tip of finger. Oh, that's perfect. That's perfect. That's good. Actually, yeah, that's perfect. Great. So we got our measurements correct. We're all good here. So we know the exact height of our vector. It's 1 point, and this is I've calculated this with my graphing calculator. Don't worry. Let me calculate it real quick. All right, good. I calculated it. That's 1.375 grooves. Easy calculation for a physics major like me. So we're just gonna hop right into this. So we're gonna start the math. So we got 1.375. That's the calculation we made. So yeah, we got 1.375. Let's make that a little bit bigger. Let's make that a little bit bigger. Great. So we got 1.375, and then we got times. Remember, the height of a groove, which is the constant. So height of, so we'll make it HG, height groove. So let's do HG. HG is equal to 15 tall. So we got 15 tall HG. So very simple calculation, as we'll see in just a moment. So yeah, we got HG equals 15 tall. So yeah, we got that. So 1.375, where HG equals 15 tall. So let's figure out the calculation first. So the formula here, and write this down, everybody. Take your notes. Is it's groove height times this number. So remember, if you ever want to figure out the height of a vector, 1.375 times HG. Great, everyone. Thank you all. So yeah, we got this right here. So 1.375 times HG. HG is 15, of course. So 1.375 times 15. 1.375 times 15. This is easy math, guys. So I don't even need a calculator to do this one. I just gotta think about it with my noggin because I'm a math physics major. Times 15. Great. So answer, bada bang, bada boom. Just calculated this with my brain to the 3rd decimal. So we gotta make the brush big because it's a big deal. So we got 0.625 tall. Alright, everyone, yeah, so that's pretty much it for today's lesson. Thought I would speak to you telepathically. So I see you've stayed. You've seen the truth. You know that we scam millions of people out of thousands of dollars when it's as easy as what Ford Technical College has demonstrated for you. But at what cost? Actually, bonus lesson. So I'm gonna be right back with the bonus lesson. Boom! Alrighty, boys, we back. Boom! So now we're gonna go on to the next part, which is measuring a curved vector. So generally, curved vectors are measured by they're represented by dumb shit, like it's just like a curvy line. But we like to have fun around here at FTC, so we're gonna measure it with a banana. Since it's like the same size. So we got our banana. So we're gonna measure how many longs is this. So this is why we first calculated the height of a groove. That was an important step in this process. because we gotta measure how many curved grooves this banana is. So yeah, let's just get right into it. So yeah, so this is a little bit more of a complicated process. We're gonna have to do some calculations here. So what I like to do in this kind of situation is I like to use some of my physics tools at my disposal. So right here we have a measure of a little ruler on my physics website. So now we got a little ruler in the bottom corner. So let's just finesse that real quick. Nothing wrong with that, using some of our resources at our disposal. So let's get this ruler. So yeah, now we're back here. Now we're gonna measure how many longs is this banana. Very simple equation for a physics major like me. So we're just gonna put this in here. That didn't work. We gotta scroll in a little more, Bubba's. Oh, okay, cool. So now we know that this right here is 10 kms. That's a physics measurement. If any of you are wondering, you don't have to know what that means. I know what it means, so you don't have to worry about it. So now, let's see. We're gonna measure the banana. Make sure you line up the measurements. So we got 1 km. We got, oh shit. We got 2 km. We got 3 km. And we got a 4 km, 5 km. Just line the kms up. So now look at this. So this is a another kind of hard calculation. It's a physics problem, but it's not anything that you can't learn through my videos. So yeah. So right here, this is what I call the Grant's theorem. Grant was a famous man. Yes. So Grant's theorem goes something like this. So it goes banana. So it goes. Let's just put a little banana there for. So it goes banana. It goes banana. It goes banana emoji. And this is kind of a niche theorem, but it's very useful in the world of vectors. So it goes banana equals x kms times I'll be right back, guys. Oh, we back. So I just have my resources, and it turns out that's the whole formula. It's just x km. So we got how many x kms? So we got 1, 2, 3, 4, 5 x kms. So we know the km equals 10 kms, and x equals there's 5 of them, so we got 5 times 10, 50 kms. So as we can all see, that's a very simple way to get the same answers that they want you to spend years studying to get, and I just taught it to you in like 10 minutes. Yeah.